see the some important question regarding the linearly dependent and linearly independent of vectors. So here we have a given question, our first question, that show that the vectors are this is of the first vector and this is second and third vectors in a two-dimensional spaces are linearly independent, right? So uh, let x, y, and z, which are belongs to the set R or real numbers, set of real numbers. So where x, y, and z are scalars, and we such that that is the we multiply the x with our first vector and plus sum with our second scalar with second vector and plus uh, third scalar with our third vectors, right? So and sum together, which is equal to this 0 comma 0 comma 0. This is zero vectors or null vectors. So now the multiplication, the vector multiplication, we have already learned at the previous lecture. So just multiply the scalar with the respective vectors. We have this, right? And we can write this. So x plus 0 plus minus z. So we have x minus z, and 2x plus 3y plus 0 give us 2x plus 3y, and then 0 plus y plus z give us y plus z, which is equal to a uh, uh, 0 vectors, right? A 0 vector, a 1 by 3 0 vector, so which give us this x minus z, which is equal to 0, and 2x plus 3y, which is also 0, and y plus z also 0. So it denoted, we mark this is a first equation, this is our second, and this is a third equation, and here the coefficient of matrix form. So here we denoted the matrix A with is the coefficient. So here the coefficient from the first equation, the coefficient of x is 1, and from the uh, okay, for first equation the coefficient x is 1, right? And the coefficient y, there is no any value of y, so here we put 0, and the coefficient of z is minus 1, right? And from the second equation the coefficient of x is 2, here put 2, and the coefficient of y is 3, and coefficient of z is 0. Okay, and from the third equation the coefficient of x is 0 and coefficient of y is 1 and coefficient of z is 1 also, and the determinant of matrix A, which give us 1, 1 is a non-zero value, right? So thus the given equation possesses only the trivial solution, that is the x equal to y equal to z, which is equals to 0, so that the vectors are linearly independent. As our the determinant just checks that the determinant of our coefficient matrix is 0 or not. If it's not 0, then the vectors are the linearly independent, and if it becomes 0, then the given our given vectors are linearly dependent. So let's see uh, our next question. So here the in the real vector the space R3, that is the vector R, alpha, beta, and the gamma, are they are linearly independent? Justify your answer. So let at the first, that is x, y, z, which belongs to set of real number v, such that where the x, y, z are unknown scalar, right? So we can represent that just the scalar multiplication with our respective vectors and sum together give, which is equal to 0, right? 0 means here the uh, null vectors. So now just value put the value of the alpha vectors given here, 0, 1, and 3, right? The element 0, 1, 3, and the beta vectors and the gamma vectors. Okay, and the vector multiplication, right? So x with 0 is 0, and x with 1 is x, and x with 3 is 3x. Okay, and beyond this we have this value, and which give us from this line we can write that 2y plus 4z, which is equal to 0. This is first equation. X plus y plus 2z is also 0. So this is two equation. Second equation, 3x plus y plus 2z, which is equal to 0. And this is our third equation, right? So here the coefficient of matrix at the first, right here the coefficient of matrix, this, and now the determinant of A, which is equal to 0. So hence the rank of the matrix less than 3, as we actually we know at the previous lecture, and have learned about uh, the rank of matrix, that any 3 by 3 order matrix give us a zero value, right? The determinant of a 3 by 3 matrix give us a give us 0, then the rank of matrix will be less than 3. Okay, we have already learned at the previous lecture series. So as the determinant of A is become 0, then the vectors are linearly dependent, not independent, right? And our third question, the determine the K, so that the set S is belongs the three vectors. This first vector, second and third vectors linearly dependent in R3. So the set S is linearly dependent if the determinant of the matrix A is 0. So what it say, that the set S is linearly dependent if the determinant of the matrix of A is 0, right? So the matrix of A is such that this, just put the first vector 1 to 1 component here along the vertical axis, vertical line, or along the column. Okay, and second vectors, the elements of the second vectors put at the second column, and the elements of the third vectors put along the third column, right? Along the third column. So now the determinant of A, so now the determinant of A we have here, the solving this, we have K equal to -1 and -2, right? So the required values of K for which the set S is linearly dependent are -1, -2, right? So which means if we put the value of the K -1 and -2 here, so which give us 0, right? If we put here the value of the K -1, -1, and determinant of A will be 0, and also if we put the value of the K2, right? So also the determinant give us 0 value, right? So this is the required values of K for which we can say that our given set S is linearly dependent, right? Okay, so do not forget, like and subscribe my channel.